Greetings, Dr. Lim. Today, Group NuOpSeven is excited to bring you on a journey in discovering more on the usage of Simplex method to minimize the total cost of goods and delivery fee in an online grocery store setting. So, stay tuned for more stories.
Hi everyone, my name is Wan Amira Balkis and I will be presenting the introduction, problem statement, and objectives. In early 2019, the entire world came into a halt due to the emergence of an outbreak known as coronavirus 19 or COVID-19. This caused a shift in demand from brick-and-mortar retail to e-commerce websites. The Organization for Economic Cooperation and Development, or OECD, reported that sales have increased for non-store retailers by 14.8% during this time. In Malaysia, the government initiated a Movement Control Order (MCO) on the 18th of March 2020 to slow down transmission rate of COVID-19. However, Malaysians preferred to do grocery shopping online compared to in-store. The online travel booking website, Klook, reported that there are 14 online grocery delivery services in Malaysia, and for the purpose of this study, we will focus on 4 stores, which are Lotus, Jaya Grocer, My Grocer, and Shopee Supermarket. With numerical optimization, we could figure out the best deal for consumers that are purchasing several items from different online grocery stores at the same time based on its price and delivery fee. For this study, we will utilize the Simplex method. Reason being, Simplex method is one of the most popular and successful method in solving linear programs, specifically maximization and minimization of a problem with a set of linear inequalities and inequalities constraints. A sample case of Simplex method is a study by Angoro et al. In 2019 where they applied Simplex method for profit optimization on a home industry bakery in Sukarama, Bandar Lampung. The dataset utilized for this study will be small, which means it will make computation less complex in solving the optimization problem. For the problem statement, we can look at it in two perspectives, which is in the consumer's point of view and the business owner's perspective. As the consumer, they would want to buy the cheapest but highest quality goods along with having the lowest fee for delivery. But if you're the business owner, the goal is to ensure that more items are purchased by more consumers, which would sometimes lead to the potential of lowering of prices of the items and delivery fee to maximize the revenue instead. Therefore, a suitable model is needed to represent the minimization of total cost from both cost of goods and delivery fee so that we can allow the consumer to get the lowest combined cost across the 4 stores mentioned before in the introduction. The objectives of this study are as below. Number 1. To formulate the minimum objective function for total cost of goods and delivery fees. We need to get the minimum objective function before we can move to objective 2, which is to apply optimization method in determining which store should the items be purchased from. So we will apply the Simplex method to determine which store provides the best price for the items. Next, the third objective is to calculate the total minimum cost from both cost of goods and delivery fees for a consumer. We need to get the total minimum cost for the best combination of cost of goods and delivery fees for a consumer.
Hello again, Doctor. As I didn't get the chance to introduce myself earlier, here goes. My name is Anik and I will briefly describe about the data we acquired. To ensure consistency, we decided to do a market research together on May the 22nd. We scoped out 4 famous online grocery stores, which is Lotus, Jaya Grocer, My Grocer, and Shopee Supermarket. Along with it will be the scoping of 7 items as you see on the left side of the table with their respective prices on the right, as well as the delivery fees at the most bottom of the table. The next sections will further describe on the usage of this sample data to help a consumer make smarter decisions, which is to save his or her total spending via cost optimization.
The objective function is to minimize the cost of the goods and minimize the total delivery fee. So in the formula, the Former part is to minimizing the total cost of the goods based on 7 items across 4 online grocery stores, and the later part is to minimize the total delivery fee for 4 online grocery stores. So in this formula, Pij is the price of the item from store J, and Xij is the binary division variable on whether item I will be chosen from store J, Vj meaning the delivery cost from store J, and Yj meaning the binary decision variable on whether delivery fee is incurred or at store J. The assumptions are as below. First, the uncertainty of the cost of goods and delivery fee is small, meaning the cost of goods and delivery fee are quite stable across the time. And the uncertainty of the 4 online grocery store is small also. The consumer can only purchase 1 unique item each from a list of 4 stores, meaning if I want to buy 30x, I just only can buy the X in one of the 4 shops. So next, the distance from each grocery store to a consumer destination is similar, such as the radius within 5 km, and the time of the delivery is within non-peak hours. No free shipping condition for minimum spend in this problem, and no delivery discount voucher applied. The system diagram of the model was visualized. So the Y1 is the decision variable whether the consumer should buy in this store, or the Y2, Y3, Y4 apply the same, whether the consumer should buy in the store, and X is the decision variable whether he will buy the item in this shop, or item in this shop, item in this shop. So X11, X12, X13, X14 only equal to 1, meaning the consumer only can buy the item in one of the 4 shops. The goal is to minimize the objective function as follows. So we plug in the price into this minimization Pij, Xij plus Dj, Yj. So 18.90 is the price for the item 1 in shop 1, and 29.90 is the item 1 in shop 2, 29.19 is item 1 in shop 3, and etc. So and here, over here, the Y1 is the delivery cost for the shop 1, and this is delivery cost for the shop 2, delivery cost for shop 3, and delivery cost for shop 4. So this minimize the objective function is subject to 4 constraints. First, a consumer only can purchase 1 unique item each from a list of 4 online grocery stores. So summation of the decision variable of the 1 item of 4 online grocery store equal to 1 only. So either this variable will be 1 and other will be 0, and this apply to other items. And next, a fixed delivery fee will be incurred if at least 1 item is chosen from a particular store. Meaning if I choose item A in shop 1, the delivery fee will be charged for shop 1, while I choose the item 2 in shop 2, the delivery fee from the for the shop 2 will be charged also. Next, the Xij is the decision variable whether I choose the item. So Xij is either 0 or 1. 0 is when the item is not chosen, while 1 is when the item is chosen. Last but not least, Yj is the whether the delivery cost is incurred in the shop J, and also 0 meaning the delivery cost is not incurred, and 1 is meaning the delivery cost of the shop is incurred. So where I equal to 1 to 7, meaning as we have 7 items, while J equal to 1, 2, 3, 4 as there are 4 shops.
Hi, Doctor, and all my friends. I'm Koilun, you may call me Alan. I'll take over the presentation with the topic of simplex method. So since we are dealing with constraint problem, we would like to apply simplex method to solve the problem above in minimizing the cost based on objective function. Instead of using manual calculation, Octave is used in this project. In this case, we will input the coefficients of the objective function to C. Then, the coefficients of constraints are input into A, and the right-hand side of the constraints, which is the bound, are input into B. Next, since there is either value 0 or 1 for all the variables, 0 is input into LB, which is the lower bound, and 1 is input into UB, which is the upper bound of the variable. C-type indicates whether the constraint is upper bound, lower bound, or equality. Since the first 5 constraints are equality and last 4 constraints are upper bound, hence we input 5S and 4U for C-type. We input 32I into V-type since all the 32 variables are integers. Lastly, we set sense as 1 since we are doing minimization. After this, we run GLPK with all the mentioned parameters. We can observe in the outcome the value of each variable in XOPT after optimization, and the minimum of objective function is 139.56. This table contains the value of each variable in XOPT shown in the last slide. It shows the online store to be chosen to purchase the specified item after optimization. The value 1 indicates that the item is purchased in particular store, while value 0 means the opposite. We can see from the table there are only 2 online stores chosen in total to purchase all the specified items, which are Lotus and Shopee Supermarket. As a result, there are 2 delivery costs incurred in this grocery purchase. This table illustrates the comparison between total cost of purchasing all items in single store and combination of items purchased from selected stores. It can be observed that delivery costs with 2 online stores, Lotus and Shopee Supermarket, are incurred if you purchase combination of items based on the optimization outcome. They are 8 ringgit and 4 ringgit and 50 cent, which is 12 ringgit and 50 cent in total. After summing up the total item cost and incurred delivery cost, the lowest cost of purchasing, 139 ringgit 56 cent, is obtained, compared to purchasing all specified items in each single store. On the contrary, buying all items in My Grosso will incur highest purchasing cost, which is 179 ringgit and 65 cent.
In a nutshell, we fulfill our 3 objectives. Firstly, to formulate the objective function in minimizing the total cost of goods and delivery fee based on this formula. Secondly, with all valid assumptions made and identification of constraints, we used simplex method to determine which store should items be purchased from. And lastly, via optimization, we managed to obtain a total minimum cost of 139 ringgit and 56 cents for the consumer, even lower than purchasing all items from a single store. Hands down, simplex method is the best optimization method due to its simplicity and cost efficiency, because every penny matters to a consumer. However, point to be noted, in every study, there's always room for enhancement. Firstly, we could consider extending our work to build a robust recommendation system for consumers with more selection of items and stores. The lowest possible combination of prices when increase in demand for online grocery shopping will provide a win-win situation for both consumers and business owners. Also, apart from just a fixed standard delivery fee, delivery time, discount vouchers, and minimum amount spent for free delivery should also be factored into the optimization model to reflect realistic logistical arrangements in stores. That is all for the presentation. Once again, my name is Anik, together with Amira, Xiaohan, and Ellen, signing off.